Hello everyone, hope you're feeling good. I'm glad to be with you in this meeting and wonderful students. Today I will talk in my presentation under the title Part 2 Protocols and Architectures. For the computer network course lectures for 4th level students. I hope you will like it. Timing sequence for service primitives. Service user, there is two components to A. Number one, confirmed service. B, non-confirmed service. Confirmed service, service user, service providers, service users, request, indication, response, confirm. And the non-confirmed service request, service user, service provider, service user, request, indication. OSI layers 1, physical interface between devices, mechanical, electronical, functional, procedural. Data link, the physical data link. Data link means of activating and discarding reliable link, error detection or control. Higher layers may assume error-free transmission. OSI layer 2, network transport. Network transport of information. Higher layers don't need to know about underlying technology, not needed on direct link. Transport, exchange of data between in-system, error-free, in sequence, no losses, no duplicates, quality of service. OSI Layer 3 session, presentation and application. Session control dialogues between applications, dialogue displaying, grouping, recovery. Presentation data formats and coding, data comparison, encryption, applications means for applications to access OSI environment, use of really. Send system, in system, real system, application layer protocol, presentation layer protocol, session layer protocol, transport layer protocol. Network data link, physical network data link, physical. Physical media for OSI, physical media for OSI. The abbreviation of the Defense Advanced Research Project Agency, DARPA, for its packet switched network, ARPANT, used by the global internet, no official mode, but a working one. Application layer, host to host to transport layer, internet layer, network access layer, physical layer. Physical layer, physical interface between data transmission device, for example, computer, and transmission medium or network. Characteristic of transmission medium, signal levels, data rates. Network access layer, exchange of data between end system and network. Exchange of data between end system and network. Destination addresses previously. Invoking service like priority. Internet layer IP systems may be attached to different networks, routing functions across multiple networks, implemented in end systems and routers. Transport layer TCP, reliable delivery of data, ordering of delivery. Application layers support for user applications, for example, HTTP, SMPT, OSI, TCP, and IP. OSI application, presentation, session, transport, network, data link, physical. TCP, IP applications, transport, host to host, internet, network access, and physical. TCP usual transport layer is transmission control protocol. Reliable connection, temporary logical association between entities in different systems. TCP BDU, called TCP segment, includes the source and destination port, CFSAP. Identify respective users' applications, connection refers connection refers to pair of parts. TCP tracks segments between entities on each connection. UDP, alternative to CP, is user datagram protocol, not preservation of sequence, no protection against duplication, minimum overhead, adds port addressing to IP. TCP IP concepts host A, host B, host A, application Y, application X, TCP IP network access protocol, and physical network 1, and contains this graphic contains network 1, network 2, and port or service access point SAP, host B, TCP IP network access protocol number 2, and physical. Router G IP, NAP1, NAP2, physical 1 and physical for NAP1 and physical for NAP2, and network. Addressing level is architectures at which an entity is named, unique addresses for each in-system computer and router. Network level address IP or internet addresses TCP and IP. Network serves access point or NCAP OSI process within the system, port number TCP IP, service access points or SAP OSI. Track of simple operations. Process associated with port 1 in the host A send this message to port 2 in host B. Process at A hands down message to TCP to send to port 2. TCP hands down to IP to send to host B. IP hands down to network layer to send to router G. Generates a set of encapsulated BDUS. BDUS in TCP IP, user data, TCP header, IP header, network header, application byte stream, TCP segment, IP datagram, network level packet. Example header information, this destination port, sequence number, checks. Some protocols in TCP IP this abbreviation of BGP, Border Gateway Protocol, File Transfer Protocol, Hypertext Transfer Protocol, Internet Control Message Protocol, Internet Group Management Protocol, Internet Protocol, Multipurpose Internet Mail Extension, Open Shortest Path First, Resource Reservation Protocol, Simple Mail to Transfer Protocol, Simple Network Management Protocol, Transmission Control Protocol, User Datagram Protocol. Diagram relationship between packets and frames. There's the sending machines and the receiving machine, sending machine, receiving machine, packets, packet header, payload failed. This is the frame, headers, and receiving machine. Service provided to the network layer. The function of the data link layer to provide service to the network layer. The principal service is transferring data from the network layer on the source machine to the network layer on the destination machine. This is a diagram of virtual communication and actual communication. Cyclic redundancy checking. CRC, the abbreviation CRC, probably the most approximation CRC, with CRC approximately 99.95% of all or 7 bits codes when for example, in the United States, the most common CRC code is CRC16 with is identical to the international standard CCITT V41 أو 41. With CRC16, 16 bits are used for the BCS entry. The CRC character is the remainders division process. There is division, quotient, and remainder. The generating polynomials of CRC16 is P of x equals the polynomial P of x equals x of the power 16 plus x of the power to 12 plus x of the power to 5 plus x of the power to 0, where x of the power to 0 equals 1. The number of bits in the CRC codes is equal to the highest exponent of the generating polynomial. The exponents identify the bit position that can contain a 1. Therefore, B16, B12, B5, and B0 are ones, and all of the others bit positions are zeros. In figure 2.6 show the block diagram for a circuit that will generate a CRC16 BCRs. Note that for each bit position of the generating polynomials where there is a 1, an XOR gate is placed expect of for x power t. For example, determine the P. This very important example. Very important example. Determine the BCS for the following data and CRC generating polynomials. Data g of x equal x of the power to 7 plus x of the power to 5 plus x of the power to 4 plus x of the power to 2 plus x of the power to 1 plus x of the power to 0, or 1 0 1 1 0 1 1 1 3 1. CRCP of x equals x of the power to 5 plus x of the power to 4 plus x of the power to 1 plus x of the power to 0 or 1 1 zeros 1 1. The first solution, first g of x is multiplied by the number of bits in the CRC codes 5, x of the power to 5 product or multiplied by x of the power to 7 plus x of the power to 5 plus x of the power to 4 plus x of the power to 2 plus x of the power to 1 plus x of the power to 0 equals x x of the power to 5 times x of the power to 7 equals x of the power to 12 plus x of the power to 10 plus x of the power to 9 plus x of the power to 7 plus x of the power to 6 plus x of the power to 5 equal the binary 1 0 1 1 0 1 3 1 and 5 zeros. Then divide the result by p of x, the result by p of x, then divide the result by p of x, and the result equals 1 0 1 0 1 1 1. دي equals CRC في النهاية اللي هو ال CRC. The CRC is appended to the data to give the following the transmitted data stream g of x equal 1 0 1 1 0 3 1. CRC equals 0 1 0 0 and thank you for your kind attention. I hope you have liked the topic today. Minute.